Imagine a world where machines transcend mere calculation. What if they could genuinely think, mirroring the complexities of the human brain? Envision machines that possess the capacity to reason, formulate strategic plans, and learn from their experiences, adapting and evolving just like us. This is the promise of artificial intelligence, or AI, a field that's rapidly reshaping our world. AI is a dynamic field within computer science, primarily focused on engineering machines and systems that can autonomously perform tasks that traditionally demand human intelligence and cognitive skills. While humanoid robots capture the imagination, AI's scope extends far beyond physical forms. At its core, it's about programming systems with the ability to understand and interpret human language, bridging the communication gap between humans and machines. It's also about enabling machines to recognize complex patterns within vast datasets, solve intricate problems using logical reasoning, and make informed decisions based on available information. AI is a universe of possibilities, a constantly expanding frontier of innovation, aiming to simulate and replicate the multifaceted capabilities of human intellect within the digital realm of machines. In its early days, AI development heavily relied on hard-coded rules, a system of if-then statements that, while foundational, proved to be inherently rigid and ultimately limited in scope. This approach, often referred to as symbolic AI, represented a crucial first step in the evolution of the field. But it struggled to effectively handle the complexities and inherent unpredictability of the real world. To illustrate, consider the challenge of defining what constitutes a cat in every conceivable photograph. With rules alone, the task becomes virtually impossible. This fundamental limitation paved the way for a groundbreaking new approach, shifting the paradigm from explicit programming to enabling machines to learn and adapt directly from data. This is where the transformative power of machine learning comes into play, fundamentally changing how we approach AI by teaching computers to autonomously identify patterns and make informed decisions without explicit programming. The ongoing journey toward achieving true AI capabilities has already profoundly transformed our world, often manifesting in subtle yet impactful ways that we may barely even recognize in our daily lives. To clarify these concepts, imagine AI as a giant toolbox. The whole toolbox is artificial intelligence, every tool and idea for making machines smart. Inside, there's a powerful set of tools called machine learning, or ML. ML tools help machines learn from experience, not just follow instructions. Within ML, there's an even more advanced kit deep learning, or DL. DL uses artificial neural networks with many layers, inspired by the human brain. So, AI is the toolbox, ML is a set of power tools, and DL is the most advanced tool for complex jobs. All ML is AI, but not all AI is ML. All DL is ML, but not all ML is DL. For example, early chess programs were AI, but not ML. Understanding this hierarchy, AI, ML, DL, demystifies the technology shaping our world. Grasping these layers is the first step to understanding the AI revolution. How does a machine actually learn? It's a question that has driven innovation for decades. We often hear about AI and machine learning, but what's really going on under the hood? What are the fundamental principles that allow a computer to learn and adapt? Let's move past the high-level analogies and look at the underlying mechanics. Forget the science fiction for a moment. We're going to dive into the nuts and bolts of how these systems operate. Traditional programming means writing explicit step-by-step rules for every single task. The programmer anticipates every possible scenario and codes a specific response. Machine learning flips this paradigm. Instead of writing rules, you feed the computer vast amounts of data, like thousands of labeled emails, customer transactions, or sensor readings. And the algorithm finds patterns and relationships on its own, without being explicitly programmed. It identifies correlations and insights hidden within the data. The result is a model that can predict, classify, or make decisions. For example, it can predict whether a new email is spam with a high degree of accuracy. It's conceptually similar to how a child learns what a dog is, not from reading a formal definition in a book, but from directly experiencing and seeing many different examples of dogs. Eventually, the child can spot a new breed of dog they've never seen before and still correctly identify it as a dog. Machine learning algorithms work in a similar way, learning to generalize from the examples they are given. They build an internal representation of the concept. The most common style is supervised learning, where the data is meticulously labeled by humans, providing the algorithm with clear examples. There's also unsupervised learning, where the machine finds hidden patterns and structures in unlabeled data, like automatically grouping customers by their purchasing behavior. The core idea is that machines can discover patterns and make predictions themselves, rather than being explicitly told every single rule to follow. This fundamental shift enables computers to handle complexity and nuance in ways that were previously impossible with traditional programming. That's the underlying power and potential of machine learning. It's a technological breakthrough that's reshaping our world. Machine learning isn't just for labs. It's everywhere in your daily life. Recommendation engines on Netflix, Amazon, and Spotify use ML to predict what you'll like, based on your behavior and millions of others. Every click, listen, or purchase refines these models, making suggestions more accurate. In finance, ML detects credit card fraud in real time, analyzing spending patterns and flagging suspicious activity instantly. Your email spam filter is another ML marvel, trained on billions of messages to keep junk out of your inbox. ML tirelessly works behind the scenes, personalizing your experience and protecting you from threats. It's the invisible engine powering your digital world. You use machine learning every day, often without even realizing it. Deep learning is a specialized form of machine learning, inspired by the brain's architecture. Its core is the artificial neural network, a system of interconnected neurons that process data in layers. A simple network has an input, a hidden, and an output layer. Deep networks have many hidden layers. Each layer learns to recognize more complex features, edges, shapes, then whole objects. For example, to recognize a cat, early layers detect edges, deeper ones spot paws and tails, and the deepest layers assemble the concept of cat. Deep learning's superpower is learning features directly from raw data, without human intervention. Traditional ML needs experts to pick features. DL discovers them automatically. This makes DL ideal for complex tasks like image and speech recognition. By automating feature discovery, DL handles problems too intricate for older methods. That's why deep learning is revolutionizing AI. Deep learning's layered structure lets it tackle incredibly complex tasks. In computer vision, it powers facial recognition on your phone and image search in Google Photos. Self-driving cars use DL to interpret camera data, identifying pedestrians, signs, and obstacles in real time, even in bad weather. In language, DL models like transformers drive Google Translate, learning grammar and meaning from billions of sentences. In medicine, DL helps spot tumors in scans and predicts genetic risks, often catching details humans might miss. Deep learning is accelerating breakthroughs in science, healthcare, and beyond. Its ability to learn from massive, messy data is unmatched. That's why it's at the heart of today's AI revolution. Let's see AI, ML, and DL in action with a voice assistant like Siri or Alexa. When you ask, "What's the weather today?" you trigger a chain of AI technologies. First, deep learning converts your voice into text, recognizing speech patterns from thousands of hours of training. Then, machine learning analyzes your words to understand your intent. Are you asking for weather, setting a timer, or playing music? The AI system fetches the weather data and crafts a natural response. Another DL model turns the text back into speech so your assistant can talk to you. All this happens in seconds, seamlessly blending AI, ML, and DL. Each layer plays a role: DL for speech, ML for understanding, AI for orchestration. This collaboration creates the smooth, helpful experience you expect. Voice assistants are a perfect showcase of these technologies working together. Let's crystallize the differences one last time. To ensure clarity on these interconnected concepts, we'll break down the nuances and relationships between artificial intelligence, machine learning, and deep learning. Artificial intelligence, AI, is the broadest concept, the overarching field. It's the grand vision of creating machines that can perform tasks that typically require human intelligence. It encompasses the science of making machines simulate human intelligence, mimicking cognitive functions like learning, problem-solving, and decision-making. Think of it as the ultimate goal. Machine learning, ML, is a subset of AI, a specific approach to achieving AI. It's where machines learn from data instead of following explicit rules, enabling them to improve their performance over time without being explicitly programmed. This is achieved through algorithms that identify patterns and make predictions. Deep learning, DL, is a further subset, a specialized area within machine learning. It focuses on using multi-layered neural networks to learn from massive, unstructured data. These networks, inspired by the structure of the human brain, can automatically discover intricate features and representations within the data. So, AI is the umbrella, the all-encompassing field. ML is a key approach, a powerful technique for enabling AI. And DL is the most advanced technique within ML, pushing the boundaries of what's possible. You can have AI without ML, like rule-based systems, where the system follows predefined instructions. And you can have ML without DL, like simple spam filters, using basic algorithms to learn from data. But all DL is ML because it relies on machine learning principles. And all ML is part of AI, as it's a method for achieving artificial intelligence. Each layer represents a deeper level of learning and capability, building upon the previous one. Facial recognition, with its ability to identify individuals from images or videos, language translation, enabling seamless communication across different languages and self-driving cars, navigating complex environments without human intervention, all rely on DL's power, leveraging its ability to process vast amounts of data and extract meaningful insights. Understanding this hierarchy helps you see how today's smart systems really work and appreciate the intricate technologies behind them. AI, ML, and DL, nested, distinct, and transforming our world, shaping the future of technology and society. We've explored the core ideas behind AI, ML, and DL, distinct, nested concepts shaping your digital life. These aren't just buzzwords, they're the engines behind your phone, your playlists, and your voice assistants. Understanding the differences empowers you to engage with the technology shaping our future. As AI evolves, it will reshape industries, raise ethical questions, and create new opportunities. The world of AI can seem intimidating, but its core ideas are intuitive and accessible. Stay curious, keep learning, and don't be afraid to ask questions. This is just the beginning. Your journey into the digital frontier starts now. The adventure is just getting started, and the map is in your hands.